of features. This is really exciting for me, and I tried to figure out how can I test them and give them a grade. Really hold me accountable, but I didn't, to be fair. But Bill's going to ask you to do a math problem, see if you can solve it, talk you through a couple things. With the previous presenters, boy, it's not even fair that I have to follow some of them. They were so great. I appreciate all the conversations and presentation material that were displayed. I love the concept. I'm going to steal from you, language of gods, right? The math language, I think, is a universal language that we communicate around the world. Rockwell Collins is a global company, and that's how we get work done, is through math. And so really appreciate that. I will steal that, by the way. Looking forward to the showcase that was mentioned as well. Well, you know what, this is my first time here as part of IDA Science, and I wasn't quite sure what you needed or what you were looking for. I wanted it to be something that you were going to benefit from, something that you would take away from today and be able to use, but also gain something from the conversation we have here in the room. And so I came up with these three things. Number one, we want to explore cutting-edge solutions. In the aviation industry where we work, cutting edge is really a 5 or 10-year technology in a lot of cases. But I think you'll see some areas of cutting-edge technology that we work in that'll really surprise you. I think it's an interesting field, a field that I've loved for 15 years as I've worked for it. Sorry, I even took a note on the first page to introduce myself with some cards, so thanks. The second thing is meaningful professional networks. I want to meet all of you and be able to help you in your jobs. I view STEM to be an area of passion for me. I have friends and girls that they're both in STEM areas and they love it. We code at home, we build circuits at home, we just have fun doing nerdy things. And in our house, nerd is a good thing, because I certainly embrace that. So if you didn't get a chance to meet me, we'll make sure that this deck is available. At the very end of the deck, we're trying to give you some references that we'll get back to later that I think will help you out. And then the third thing is provide STEM opportunities for your students. That's why you're here, I hope, not only to learn for yourself, but also for your students. The whole point of teaching is just a great profession. And without you, I wouldn't be here, Bill wouldn't be here, and a lot of other students wouldn't get as far as they do without all of you. So thank you for making the efforts that you do. So with that, I wanted to give you a brief history of our company. Rockwell Collins has been around for a long time, and it was founded by that man in the middle, Art Collins. He was in his garage building a ham radio, believe it or not. His dad was a farmer. He was able to at least buy enough expensive vacuum tubes so that he could piece together a radio. And he was able to communicate to a Navy fleet that was in an Arctic expedition where the Navy itself couldn't actually communicate to him. So he was an industry leader. He was 14 at that point. I remember how old he was. Was a pretty interesting guy. A lot of people don't know him in the radio industry, and yet he really is one of the architects of current day radios. In the upper left, he was able to help build an antenna and a station that was down in the South Pole, where we were able to communicate throughout the world as well. Without that communication device, those people would have no way to communicate at that time. And in the upper right-hand side, that's in the 1960s. You guys probably all remember this event. If you've been around, you certainly have. There was a comment made by a guy who took foot on the moon, one small step for man, one giant leap for mankind. That was done over a Rockwell Collins HF radio, which is pretty cool to think that our radios went to the moon and are still there, actually. On the bottom left, we as a company had our first transatlantic GPS flight. So when Dr. Maurer was talking about the precision of positioning throughout the globe, it's interesting. Without that technology, GPS technology, you couldn't do that. And we use that same technology in airplanes. And in the bottom right, some of our solutions, we call them surveillance products. And they're not surveillance like we're listening to your phone or tapping your houses. This is more surveillance where we look at situational awareness. As a company, it's very important for us to provide solutions to the marketplace that tell the pilot of an airplane what's around him. And so surveillance is one thing. Weather radar is a product that we build. It sits on the front of the airplane. we send out an RF pulse and listen to it, and then it comes back and it tells us what weather's out in front of the airplane. Or another solution may be that we send out a pulse and listen for other airplanes that are around. And those other airplanes respond back and say, okay, that way airplanes don't run into each other, which is a really important thing in our industry. So when you talk about the aerospace technology, what is it like today? I gave you a bit of history. It's pretty complicated. You know, there's a lot of things going on. And just to show you a couple of them. Can you guys still hear me in the back? Yeah, okay, great. How do you build the satellites? This is the map of what's out flying around the Earth in the different orbits of the different satellite systems that are out there. From anywhere from you take a geostationary orbit all the way down to a LEO orbit. Things like satellite communication, there's government systems communications, there's the Hubble Space Telescope. ISS station also flies around here. When you add up all these things, boy, it's a really complex airspace. In addition, when you look at all the airplanes that are flying around airspace and communicating, it gets to be a complex system that we have to think about. Because when you're talking over a wired line, let's say you have a phone that's connected through a wired line, it goes to a single point and you can connect those 2 points. When you talk on your cell phone, you're starting to use radio waves that communicate over the airspace. And when all of those things are communicating at the same time, you all pick up your cell phones and try and have a conversation. The system gets very, very complex. So that's another thing that we have to deal with in our industry. In addition, the systems become more and more complex as time goes on. So if you remember a computer that you may have seen years and years ago, maybe it was an Apple IIe. An Apple IIe, you had to slip in the floppy disk and then insert a computer and then write, and then you could make all these kind of grinding noises on the disk. Finally, you would boot up and give you a cursor that you could do something with. When you compare that to your phone today, your phone is so much more complicated than what that original system was. Those are things that we're dealing with in the industry, and they equate to big data. And this is a problem that the industry is going to face as time goes on. There's a lot of data out there. How much of it's important, how you use it, is going to be a key point. So I want to show a quick video. I have a couple of them, and I think Bill does too. We wanted to at least keep you focused for a while, but I will grade you on it later. This is a Rockwell video we made a couple of years ago, which tells you a little bit about who we are and why it's important.
Here at Rockwell, engineers are the backbone. The driving force.
Company, tradition, innovation,
all part of success.
Today, the world is moving faster than ever.
And it's up to me. On me.
Help Rockwell Collins succeed.
Today, the bottom line matters.
More than ever.
It's up to me to strengthen, work smarter.
Find new ways of doing things.
It's up to me to use lean.
Think lean.
Live lean.
In every step of the process.
And keep our solutions.
Cost competitive.
It's up to me to think flexible.
Because today doesn't look like yesterday.
And tomorrow won't look like today.
I need to be agile.
Adaptable.
Nimble, responsive, bendy.
To make sure my solutions are too. It's up to me to think different. Lead different.
It's up to me to help my customers think ahead. And even around corners,
It's up to me to come up with the next
the
thing.
big thing.
The right thing. And be willing to stand up.
Stand up.
Stand
I
up.
can share my ideas with others.
In the next office over,
Or halfway around the world.
I am the foundation.
The backbone.
the driving force.
I am part of one team.
One vision.
I am a Rockwell Collins engineer.
我是一名 Rockwell 工程师。
मैं एक रॉकवेल कॉलिंस इंजीनियर हूँ।
Yo soy ingeniero de Rockwell Collins.
Je suis ingénieur à Rockwell Collins.
Hice la de Rockwell Collins.
Soy ingeniero de Rockwell.
我是洛克威尔柯林斯公司的工程师。
Rockwell Collins Mate Contribution.
मैं एक रॉकवेल कॉलिंस इंजीनियर हूँ।
I am a Rockwell Collins engineer. And now, it's up to me.
So I wanted to give you a sense of who we are, and I thought it was really important in that video for a couple reasons. The theme that you see is more about people, it's less some people's lives where they could get turned off. Women are one of the areas that I worry about most, but it's just more than just women. There's also other aspects of minorities, certain groups of people. They can all get turned off from STEM, and I think you can help them not get turned off by STEM. It's challenging them and listening to them and asking why, letting them fail, letting them learn from those situations, I think are really key in building them up as you go forward. What's interesting is that women up to a certain age are very involved in STEM. And when I go to the science fair for the Brevard schools, it's interesting to see the number of women involved in those science research programs, that they're greater than 50%. They outnumber the boys. And yet, later in life, somewhere they get turned off. I don't understand why that's the case. And some people simply go into some other degree or something else. I think you look at this room and you lose half of the population when you take just women out of the solution, let alone other minorities or other people for other reasons. So I encourage you in your job, think about that. When you see someone disconnecting from a STEM field, re-engage with them. Ask them, hey, is this exciting for you? Like it? Why do I see you disengaging? I think that's important. One other video that I had before, I'm going to give it to Bill. We're the key sponsor for First Lego League. Has anyone heard of First Lego League? That would be great. I think those of you who haven't, it's a pretty cool program. I'm going to show a video. She's going to tell you a little bit about it. We'll see the impact it has on kids.
At Rockwell Collins, we are very concerned about the future of our workforce, and we're doing what we can to develop a strong engineering pipeline, really to fuel our business and to fuel our economy in general. For us, it's an economic development concern and a future workforce concern. So we really see FIRST as a way to engage young people and help them understand all of the opportunities that there are in engineering, science, technology, math, so that they can begin to imagine their futures, hopefully in those careers when they grow up. Rockwell Collins has been involved with FIRST since 2002. We started very small, sponsoring just a couple of teams in Iowa, and we have grown to become a FIRST strategic partner, and we're also the program sponsor for FIRST Tech Challenge. So over the years, we've grown from a very organic grassroots, a couple of volunteers, a couple of mentors, to really, it's part of our larger STEM strategy and aligns with our philanthropic giving. I believe kids make great inventors because they have an unlimited imagination. They are naturally thinking out of the box. They have unimaginable curiosity, and those barriers that we develop as adults are just not present with young people. So the sky's the limit as far as young people's concerned with inventions, and I think we're seeing all of that here today. They also learn about teamwork, and they also learn about failure and how to pull yourself up after you fail and to try again. And those soft skills that really are very, very important when you get into the world of work, and also just in general, as a person, becoming a strong person. As far as Rockwell Collins' relationship with FIRST, we're just hoping to continue and to grow and to engage more companies and really just to continue to do the great work I believe that FIRST is doing.
Has anyone been to a First Lego League competition? Yeah. The first time I went, I was blown away. I mean, the energy in that room, they played loud music, and the kids start screaming and yelling when the competition happens. It's really neat to see kids get so excited about a STEM event and see that excitement from kids. It's neat. Well, I wanted to introduce Bill. Just give me 1 second, Bill. One thing I've learned in leadership in my years of experience, 15 years in engineering, surround yourself with people that are smarter than you. So that's what I did. I had Bill on my staff. Bill's been with Rockwell Collins for 29 years. He was named the Rockwell
So before we start the video, what I want to do is, we've talked a lot about the STEM students, the students that are clearly the STEM people. But as Dan pointed out, there's a lot of places where we're losing a lot of kids. And part of it is they don't understand how STEM affects them. They don't see STEM. So what I've got is one presentation right now that I want you, as you watch it, I would like for you to do an exercise that you can do with your students, which is show a video and document where is STEM involved in what's going on.
And then we're going to grade them.
And then, yeah. So he doesn't get to grade, he gets to grade you, but I get to do the exam. But anyway, but that's what we're looking at, and I'm trying to get this so you guys have some additional concepts for how to get the kids engaged that really aren't STEM gung-ho. Because the reality is STEM's everything. And whether they like it or not, everybody that is born in the last 20 years and from now on is going to be embedded in STEM every single second of their life. So we'll go ahead and play this. And this is, again, it's from Rockwell Collins, but it shows a lot of things. So see what you can come up with. We're going to ask about it.
Deep inside the human soul, there's a passion. A passion that moves you. A passion that reaches out for you. A passion that drives you.
Submit that there's not a single video on YouTube that you cannot do this exercise, and they'll be amazed at the amount of STEM that's reflected in any video you pick on YouTube. So aviation and STEM, and this is actually not just aviation, by the way, but everything that's built, everything that anybody builds, including Rockwell uses models of the real world. And we create those models of the real world based on STEM. Whether it's in chemistry, physics, engineering, pure mathematics, applied mathematics, the world has to be modeled in order for us to live with this, because we can't encompass all of it. We can't embrace what it really is. And so it's so complex. What we do is we create models. And we create models, and we use those models, and we use them until what? We use them until we find a case that doesn't work. And when we find a case that doesn't work, we refine the models until the models again work with the data we've got. And they have to work not only with the new data, but they have to work with the old data. And the classic is moving from Newtonian physics to Einstein's physics, relativity, right? The models that Einstein came up with had to be able to support all the findings from Isaac Newton's physics, but it had to extend so that it applied to the new data that we had that didn't fit Newtonian physics. It's constantly going on all the time. And so these are the questions that we wanted you to look at. After we do another video in a few minutes, we'll go ahead and talk about, we'll show what I've got out of it, and we'll see how you guys did it, all right? So, modeling the real world. Why do we do it? Because we want to know why this event occurred or some event didn't occur. So what we do is we sit down, we think about it, and we postulate reasons for why the event either occurred or didn't occur. We build the model that supports our postulates. Then we test the model with data, and in some cases we go out and look for more data. And then we revise our postulations and models based on the data, the tests that we do. Step and repeat. The way the world has worked from the beginning, and it'll work until it ends. Because we're always learning more, but we never know everything. So, it's very interesting. We did not coordinate with Dr. Mall. But I've been doing navigation for longer than my 29 years at Rockwell Collins. And so I chose that this is how models, we can show pretty clearly the difference in models and why you use models. And the model that Dr. Mall talked about primarily was the spherical geometry-based model. But there's Euclidean geometry was used first. And it was used to model, to calculate navigation until they started realizing that it was inaccurate. And so the Euclidean geometry is based on what they call a planar navigation. Right? So it's just a two-dimensional plane. And you're looking at, you have your points in Cartesian coordinates, latitude and longitude in this case. And you have your reference is north up, and then east is to the right. So there's your orthogonal axes for your measurement. And you just have a point V and a point T, and to calculate the distance and the bearing to go from V to T, you've got a set of equations. They're all based on the Pythagorean theorem. Just straightforward. It's just Pythagorean theorem straight up. Right? And it's accurate, but it's only accurate for short distances. And that distance, depending on the accuracy you're trying to get, is anywhere between 12 miles and 60 miles. And it depends on where you are on the Earth. Because again, as you get towards the poles, then the curvature plays in more heavily. So we started out navigating a long time ago with planar navigation, because they could do that. It was relatively easy to do. Then they started finding out that it didn't work. When they started going beyond line of sight, they did start going longer distances. So what they do they created a new model. The new model is the sphere. And then they use spherical geometry and they use the hammer sign formula. They calculate the same things from going from point B to point T, the bearing and the distance. Now, one thing interesting to note here is that in Euclidean geometry, the bearing from your origin to your destination is a constant. It's not true in spherical, and it's not true in the world. So this is accurate over long distances, but it's not the real world. So as Dr. Mall mentioned, it's been shown that the Earth is actually an oblate spheroid. Right? So that means it's an ellipsoid of revolution. You take an ellipse and you just rotate it, right? So it's basically take that sphere and you squash it. Okay, so it's based on ellipsoid of revolution formulas, and it's the basis for Dr. Mall also talked about geoids. So in order to make your navigation accurate, what you do is you create a definition for the ellipsoid of revolution to match surveyed data in the area you want your accuracy. And so the oblate spheroid navigation is a best fit, but only in specific regions. So there are as many geoids as there are people in this room probably. And each one of them is accurate in a different region of the world. And they're used for different mappings. So one of the struggles that we had to have when we started going globally is everybody had their maps done to their local geoid because it was accurately represented their area. When you start trying to move from one geoid to the other, the mathematics to do that transformation is relatively complex. It can be done, but it's relatively complex. So what they did is they started coming up with a global optimization. You had the least mean squares error across the globe. And that is the WGS 84 geoid that Dr. Mall referenced that was updated in 2004 because we had additional survey data from the space satellites to help improve the definition of geoid. So this is much better. And you can see here the polar diameter is different than equatorial diameter. Okay? But it's still not right. So what you see here is you see the actual terrain in the oceans. And so this is a highlight of the upper section here on the right. And then you see the red dotted is the ellipsoid for the geoid. And you see that it doesn't match everywhere, right? It still doesn't match. As good as we've made it, it still doesn't match. But now the other thing to notice is that the Earth isn't quite an ellipsoid of revolution. They've actually said that the best representation of the Earth's shape is an ostrich egg laid on its side. It actually has one side is actually slightly smaller than the other. And all of these measurements have been taken from Earth.
Is that east-west slightly smaller than the other, or is that north-south slightly smaller than the other?
So it's squashed north-south.
Right.
So east-west has got the longer diameter to the north-south.
And so then east-west, the west being the Pacific because there's more water, so it tends to be flatter than the east, which has the Himalayan mountains and the Alps and.
I suspect it has some stuff. I haven't really looked at that particular aspect of it because that's far. You use a model that's most representative of what you're looking for.
Right.
And these models are clearly you're looking for some kind of terrain, right?
Yeah.
You're not looking for, like for airplanes, all we're looking for is a radius out from the center of the Earth, right? So it's good. The soil is going to be more than enough for us.
Right. Bill, can I make a comment on that?
Absolutely.
Being a teacher, I teach geodesy, this one called planetary system. So let me take you, Bill, give me 2 minutes to stop me. So the radius from here to here, compared to the radius to the pole, the difference is 21 kilometers. Radius at pole is 21 kilometers less. And what makes it more interesting, radius at south pole is slightly shorter than the radius at north pole. Remember when we were kids, they were asking us to draw Earth and we draw it like an apple, just go inside? I think that we had something. So it's actually the south pole from the center of the Earth. The south pole, this radius is slightly less. What is the tallest mountain on Earth? Himalaya Mountain, right? Himalaya Mountain. But it's Himalaya Mountain, how much is, what is Everest Mountain, right? It's what is, no, wait, we get to the ocean first. Let's start with the continent. So, what is the height of that? It's about 8 kilometers high. The tallest mountain in the solar system, of course, is on Mars, which is 23 kilometers high. That's Olympus Mons. So 8 kilometers high. So if I am flying over Himalaya Mountain, I have more rock between me and the surface as I'm flying over the ocean, right? And that rock is mass. Mass means gravity. So if I'm flying over a mountain, I expected to see the effect of 8 kilometers of rocks. Are we in phase? Yes. It's like a laser. That's why the laser is good, because all the photons are in phase with each other. It's coherent. So I expect that the gravity is going to be higher because of 8 kilometer mountain. But you're going over there, you have a gravitometer, instrument who measure gravity. Simple pendulum is measuring gravity. Now you have a sophisticated one, but simple pendulum measure gravity. You make a gravity measurement over Himalaya Mountain, and you see the mountain appear as a 400 meter high. 400 meters. What happened to the 8 kilometer height? Right. This thing is actually on the gravitational map is appeared as a hill. Now you go over ocean. What is the average depth of ocean? 5 kilometers. The deepest part of ocean, 11 kilometers. You take Himalaya Mountain and then you invert it, the peak doesn't reach the bottom of the ocean, okay? Now you go over the ocean, 5 kilometers, mass is missing, rock is gone, you put the water. So you expect that your gravity is less because now you have less rock between you and the center of the Earth. Correct. So you're going over there, you say that, okay, my gravity should go down because now the rocks are gone and it is the water. And you do the calculation or you do the pendulum, or you're using pendulum to measure your gravity, and you see that 5 kilometer ocean appear as a 6 meter ditch. No. And that's where your students are puzzled. What the heck is going on here? Why I don't see the effect of the mountain? Why I don't see the effect of the ocean? So that is for the next episode. So you look at the word isostasy. 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 That is, and who explained the isostasy? Archimedes. Goes back all the way to the Archimedes principle. So the geoids are very, very friendly, and that's how we know what is in the belly of, I did these things for Jupiter. How do we know in the belly of the Jupiter there is an Earth, the size planet, actually 25 times the size of Earth? How do I know that? How do I know that? Nobody put the seismometer on the surface, there is no surface, but nobody put the seismometer on the top of the Jupiter to know that there is a core, the Earth size, well, Earth-like planet, a rocky planet, 25 times bigger. What is the radius of Jupiter? If I ask you, everybody in this class, you don't know, but I'll teach you something. Between friend, Radius of Earth, 7,000 kilometers. Now you want it exactly 6378.145. Between friend, 7,000 kilometer radius of Earth. Radius of Jupiter, 70,000 kilometers. Radius of Sun, 700,000 kilometers. Between friend. So how many Earth fit in the Sun? You have the radius, you know the volume, and maybe you know it. So that's how we knew with this geoid measurement from disturbance on the satellite, perturbation on the spacecraft, what is inside of the tube. So maybe some other time around the campfire, I will teach you. Bill, floor is back to you. Thank you.
So another thing that I thought would be interesting is maybe you can relate to this. How can you tell when people are STEM oriented? Their favorite question is why. They prefer hands-on to hands-off. They pick up items even when they're not supposed to because they want to look at them more closely. They like to take things apart. Sometimes they'll try to put them back together. The Lego League is really good because it's reversing that. So that's really good. Interestingly, they are interested in music. They require more from you as a parent or as a student, right? They're always pushing you, right? And they push the envelope, whether it's your rules in the class, whether it's why do I have to do this? Myself, when I was in 5th grade, my mother keeps telling me this. It was time for me to learn the multiplication tables. And
Why?
number one is why. I said why, and they couldn't tell me why. So I said, well, I'm not going to do it. So the interesting thing is I've ended up in engineering and I do math in my head all the time. So that tells me a couple things. One is recalcitrance to do some things when they don't feel they've got a proper reason to do so is not an indication that they aren't STEM capable. And two, you never know where you're going to end up. So it was interesting. Encourage curiosity. Try to get engagement, active participation. Look for activities that can help with that. And I think I can speak for Rockwell Collins, but I suspect I would speak for all of industry that we're willing to help engage. If you see something that you would like engagement with, clearly FIT is interested in helping you. Industry is interested in helping you because we have a vested interest. The engineering STEM education is at least leveling off. For a large number of years, it was a significant decline. And the reality is we need STEM because it is everywhere. You cannot get away from it anywhere, any place. So, where did my other... Okay, so we're going to show this video first. And then we're going to say... Okay, so this is a little different than the other video, but it's equally interesting. Same questions apply. Each one of those dots is an airplane. So, how'd you do on finding STEM? So, this is what we've got. Algebra, geometry, trigonometry, calculus, differential equations, tensor calculus, vectors, matrices, stochastics. Chemistry, physics, we need the elements, materials, physics of solids, statics, dynamics, optics, engineering, computer science, electrical, civil, aeronautical, chemical, industrial, computers, software. Both those videos encompass all of that.
Left out the environmental impacts.
Environmental. So you look at all this and people take all this for granted. So the first step, I would say, in STEM education is getting people to open their eyes. Get them to realize that they are immersed in STEM. They cannot get away from it. The Amish can't get away from it. If those people can't, nobody can. So at that point, I'm gonna give this back to Dan. Yeah, sure.
Are we producing enough engineers in this country?
No.
Yeah,
Simple answer, no.
yeah, I agree.
Yeah, that is why,
Do we have enough engineering institutions in this country?
no, I don't believe.
Well, I think we do. The issue is that if we don't start getting more students soon, they're going to start getting smaller and they won't be capable of taking the
Because
students.
our engineers are aging. My father was a double E.
Yeah, I'd like to chime in on after Bill. I read an article about 4 or 5 years ago about the capacity that the U.S. colleges had for producing engineers, and it didn't fulfill the world need, just didn't, but the U.S. need. We have to go outside in order to support the engineering efforts that are done in this country. So, to the extent that we need it in, maybe not, but I tell you, all the engineering engineers I know have jobs. I mean, they don't sit out, you know, I mean, I don't know many out-of-work engineers that can't get
Want to
by.
work,
Well,
as engineers.
that desire a job, right? So there's some that I know that are sitting at home and enjoying their lives.
And their actually pay scales higher.
Depends on which one, absolutely. You know, there's 4, I think, recognized professions by the U.S. government. Being a lawyer is 1, being a doctor is 2, being a CPA is number 3, being an engineer is number 4. Out of those, engineers probably are on the top of the ranks. We don't get paid what a doctor gets paid. But I tell you, from an average general job, it's much higher paying. And you have to be able to do math, but math isn't that hard when you have a great teacher. Math isn't that hard when you work at it. And so, go ahead.
Well, I guess one of my concerns is as a scientist who pretty much goes to school right next to engineers, and then you come out and you're not an engineer.
Yeah.
So the titling of this, you know, when we say, do we have enough engineers, is there possibly
A mixed issue, like a...
Yeah,
so
because you can't sit for that title without this, that, and the other, and yet, you know, all that stuff is research, physics,
There's chemists, there's physicists, there's, you know, other fields that also can do STEM-related jobs, right? We have some of those. We have mathematicians on our staff, as an example, other degrees. It's not as common if you're a mathematician but have never been taught electrical theory. It's kind of hard for you to design a board without gaining that knowledge somewhere. You have to desire it, but I think it's doable.
Yeah, clearly, the semiconductor industry is a classic case. They use a lot of chemical engineers. They use a lot of chemists.
Right.
Because everything they do is chemical based. So there's a lot of different areas, and we have gotten better at using non-engineering STEM people in the appropriate jobs, but we're going to need to get better. Because even when you expand engineering to encompass all of STEM, it's still a struggle. Because kids, they don't see the excitement. But then that's going to be the hard part. I mean, and some of these videos, that's the part of the reason we do these videos the way we do, to get them so the kids can, hey, I can get it.
It's the coolness factor.
Yeah.
You gotta get them loud, because they sit there on their cell phones constantly. And they get all bombarded, you know, but they don't see what made that cell phone. They don't see the relevancy to the cell phone, that's engineering, that's STEM, right there.
Yep, absolutely.
Can I follow up that with just 1 second? Because like as a teacher, you can come in through alternate pathways and bring in that outside. So I guess, like, because when I say engineering, when we say STEM, but I hear the E more than I hear the STM. And I guess I just, you know, as people in the industry who want us out there, this alternate pathway, if you will, who actually, they do the engineering and stuff as well.
Well, I would encourage them to do the smart thing, and that is if you want to be an engineer, get an engineering degree, right? If they don't know what they want to be, but they love math, tell them to take all kinds of math. They still have those opportunities. You have to fight a little harder for it, but it's not an undoable path. If they're passionate about it, I bet you they'll find a solution. I've seen it time and time again.
As a dean of science, I will tell you that if we stop science, engineering will die tomorrow.
Yeah.
Thank you.
That is.
I care about science.
Yeah.
I'm going to publicly say that. Neil deGrasse Tyson's my hero.
One thing to remember is the first year of engineering, they take chemistry the entire year. The second year of engineering, they take physics the entire year. And in both years, they take calculus and differential equations in both years. So engineering its foundation is math, chemistry, and physics.
And there is no boundary. There's maybe outside, there is no boundary. It's in the knowledge. These are all pushing the boundary of knowledge. So you start with science, and then you go apply science, and that applied science becomes engineering. All the foundation, of course, is my beloved math. I tell you, the most expensive faculty that we hire in this university are mathematicians. More than engineering, more than scientists, more than physicists. Mathematicians are the most expensive faculty.
That's why I don't work here. She's been waiting so patiently to ask questions. It's like the best student in the class.
In my grad school experiences, I've got an EDS in Science Ed, a master's in engineering, and then undergrad in art and English. And so it's allowed me to see in many different perspectives, and particularly the development of kids. And I wish that industry would look at all of these different disciplines as intertwined. And I wish that they would treat the worker that way, pay the worker that way. And we would have enough engineering graduates, I think, if we would embrace diversity, pay women more, and quit stereotyping professions, because culture goes through like 30-year sine waves where we have specialist generalists, and thank God for programs like Florida Tech's undergrad, where you have to take, to round out your education, you have to take a lot of different courses so that you become kind of a world citizen, if you were. And if we did prepare our students that way, maybe a little bit throughout their whole college career, so they mature along with the knowledge base they learn while they're in college, and it's applied, they're ready to work when they graduate. We would have enough engineers and scientists and whatnot, because it's a shared work experience. It's a teamwork. It's a team environment when you work now. And so you need to be useful not only to yourself but to the rest of your team. And the U.S. is going to keep falling, past number 30 or wherever we are now in terms of worker usefulness in the workplace.
I'm available all night, so I will go on with these questions all night, just so you know, because I love these type questions. I want to start from my view of economy. I believe in capitalism. I believe in our democracy, and I think that people get paid what the market values. And just like our products as rock columns as we sell in the world. So I think there's a natural area that tends to pay people for what they're worth. In my personal opinion, and this is honest, I've told this to my wife, to my kids, to other people that I'm in circles with. If we really care about the society as a whole, we should pay teachers more. And I'm not saying that because I have a room full of teachers. I'm saying that because if we really want to make a difference in society, we pay teachers more, because that's who the closest people are to raise the kids of tomorrow, to teach the kids of tomorrow what the society is going to be like tomorrow, and give them the best education. So if we're gonna pay workers more for what they're worth, let's start with you, and we'll move on to the people that are in the workplace. Sorry, I saw 4 or 5 other hands.
One real quick thing, I want to follow up on your comment on getting some of the humanities education with the engineering. I think that's so important. When I teach science in school, part of the thing is collaboration and communication. Okay, being able to work together, even with people you don't like, okay, and being able to talk to them, and being able to commit to dates, and being able to commit completing something you've been assigned on your team. Not that I assigned it, but your teammate did. You collaborated, you figured out what needed to be done, you divided up the work effort, and then you committed to getting it done by that time, and then turning it in, and then holding each other accountable for it. That's a skill that has to come with the competency of being an engineer, or being a science person, or being a physics person. You can't just sit in a white room with a lab coat on, working calculations. Now, God knows there's some people like that, and we need them. But the majority of the people got to work with people. And that's a skill that we all have to teach these kids to do, because they all like to sit there like this and not talk to one another. Put it down and start talking to each other.
I tell you, I talk to my kids in my bedroom, I text them now. I don't talk to them. You know, that's the way they hear me, and we'll go over and have words and real conversations. But look, if you want to connect with people today, you got to use their medium too. So
Okay, so I teach biology, so I'm looking at all that going, I really still really love my life
Well, I
science.
got a future for you.
Okay,
go
well,
ahead.
so I spent last summer all over the place. Went to University of Florida and worked in a genetics lab for 2 weeks through the US CPET program, which is designed to help teachers bring back technology and biomedical engineering experiences to students to help stimulate interest, okay? I brought those things back to the classroom beforehand. I did a pre-survey and I did a post-survey. And what I found was that students, before they've gotten that kind of exposure in the classroom, they have a very negative impression of engineering unless they have a parent or a relative who happens to be an engineer or a person who lives next door. They've met them, they understand what engineering is, because a lot of our kids don't understand what it is, and when they think of it because of the math involved and so on and so forth, it has negative connotations. The post-survey revealed, after doing all these activities, including building drug pill coatings and trying to design an angioplasty, they had new words for it. It was fun, it was helpful, and there was definitely a greater interest in pursuing that. I think that as teachers, we need to give them those experiences, and the reason I brought that back with that survey focus in mind was, I started going like, wow, what would if I've become, if my high school teachers had done this with me, and they didn't. And I was bummed about that. I still love my science and my biology stuff, but I sat there and went, wow, ghost heart organs, these are so cool. I could have totally gotten into this. And so it was the kind of thing where I brought that back. I will tell you that going up to University of Florida for that kind of thing is very cost prohibitive for teachers in the area. You know, we don't have access to the equipment that we need to be able to do these things in the schools. And just trying to get a charter bus to go up there costs $1,000. If there was a way that FIT could partner with teachers in the area to provide some kind of experience like that, I think that would really be a real step in the right direction to helping teachers locally to further the interest in STEM in our youth, such that we have more exposure. No, I didn't bring students, I just stayed.
Yeah,
I
because
couldn't
you
do
can't
students.
even do it. Like, I always just like, was like, I just don't have the time, energy, money put into bringing students out there.
Right.
However, I checked out equipment from that.
Right.
Equipment locker after working in one of these programs. You know, just simple things like pipettes, you know, just like
Right.
doing like, just simple techniques, teaching them how to use a pipette, like little things like that. Where they're like, wow,
Absolutely.
this stuff. It's the simplest like tool ever.
It's not just a cartoon.
Yeah. Those are just little things that like I feel like could really enrich and like get kids more interested in seeing what kind of fun tools we can use.
I agree with that. I mean, I wouldn't just lean on FIT, I would lean on industry. All your students have parents that work. I tell you, I've never seen a engineering-rich community like we live in. I tell you, I think that there's probably an engineer in every 3 households here. And so you can pull on those people, the ones that can communicate, not in all engineers, but communicate. You know, they have the joke, you know, most engineers look at their shoes. An extroverted engineer looks at the other person's shoes. Bill and I think make it to the knees sometimes, but we're still engineers, so remember that. I do think there's people out there that you can pull on. Industry will get involved. I know Harris locally contributes a lot of money because this is their headquarters. Northrop Grumman has made a huge move here. So, yeah, and we will too.
That's
Rockwell
awesome.
will too. So.
Well, and that, I would say, is probably the biggest thing. We'll have people come in, I forget who does the circuit, they may do the circuit boards with the people, they'll come in. Who is that?
Space Coast Fab Lab?
No, it's Northrop Grumman. Yeah, they come in, but what's great is they're doing the circuit labs, they're the engineers, and they talk about, oh, guess what I do? And one lady, and the kids are like, wow, that's engineering. I mean, we had somebody who she does the ergonomics of an airplane cockpit. You know, who knew, right? And even as teachers, who knew when they say they want to do engineering? Wow, did you know that? So it does help. We had other people come in and they'll bring in an activity, an engineering activity
I don't, a lot of this is something that I see again and again, bring these experiences back into the classroom. What we face is we are standards-based, so there's very little we can do. And yes, it's great to teach kids about the natural world, but once again, the world that they interact with. I have a proposal on the table to our principal, the superintendent, the assistant superintendent, and there is a section in there about, you know, without being obviously facetious, we can't call ourselves the Space Coast anymore. Elementary, middle school, non-existent programs. I don't know if you guys are aware, Dr. Blackburn, our new superintendent, has a new initiative called Project 2018. He's going to start at the high school level and work his way back to try to get STEM into the classrooms. It's just, it's not there. And it's fighting to get these and you know, my daughter's third grade teacher's like, oh, we built spaghetti towers today. STEM. And I'm like, I don't have the heart to tell her it's not STEM. You know, and it just those mundane tasks they're not STEM. We need programs, and we just don't have them on the Space Coast, and we have to address that. And the other thing, the project Dr. Blackburn, and I was all excited, and then the woman said, so next year we're going to bring some teachers in, and we're going to design some curriculum. I'm like, but why? You know, why are you going to spend a year with teachers who don't have a background in this to design curriculum? I'm trying to get Project Lead the Way into our classrooms, but I keep hearing about it's a lot of money. I was like, well, we have to change something. So I'll probably be harassing you guys at some point. Someone at your company for money.
I say no all the time, so I know I won't say
Okay. But I need you to know that there's really, in this county, Brevard County, there's really nothing for STEM.
I think are available for you now. I don't think it's rich within our environment and community. I think it does need to grow quite a bit.
Yes.
But I think there's some areas that we can all help grow a little bit.
Yes.
So I'm trying to do my little part, Bill's trying to do his little part, you all will do your little part, and hopefully together as a society and community, we grow together. We have a STEM-rich environment. And boy, you know, there's no other community in the U.S. that has the opportunity that this local community does. I tell you, I look proud. We're like the number 7 technology corridor in the U.S.
Really?
In the U.S.
Wow.
And we're the second fastest growing. And so you think about things like that, and what can we get STEM to the kids, right? It's like, come on, we can do it, right? That's what I think.
You probably already know this also, but because of the port and the and Kennedy Space Center, this is the only location, I forget whether it's global or whatever, that has 4 avenues of transportation. Yeah.
Right.
Yeah, so you,
4 avenues of transportation.
Yeah. You have rail, you have roads.
Yeah, you have the highway on 85, you've got the rail line, you've got the shipping line, the port, and you got the airport. Yeah. And Kennedy Space, and the space port.
Modes of transportation has contributed.
Yeah. Pompey High is probably one of the poorest schools in the sense of the area in which they live, where the actual school is located. There's a poor population that feeds into it. So we don't have much in the way of engineers, shall we say. But once a year, we do have a program where we invite anyone we can get from the industry to come in to our school and talk about what they do for a living. Now, we get a lot of people from, I had somebody from the zoo once. I mean, policemen come in, people from the Army and the Navy and all those come in. But I would like to see us just get some engineers in there and try and inspire some of our students, even though they don't have the scholarships or the this or the that, to try for something like this.
You'd be surprised what engineers live in Palm Bay. Just no kidding, when they do.
Well, they live in Palm Bay, but they go to Harris and places like that. This is the West Melbourne. It doesn't really matter where we are. The point I'm making is we have.
Looking back on industry, I think we can support just having someone there in that career day. I have no doubt.
Not someone. I want to see it.
Well, remember, we are all for-profit companies, and so.
I understand, but it's one day a year.
I agree.
And this is your chance to inspire. That one time.
Thank you for taking the hot seat.
I can't help it. I don't have a chance, another chance.
last year, he's all this year.
Who do you call?
Hey, Juliet is the best person.
I wouldn't say, I want to follow up on our comment about engineers, okay? And that it's a poor school, and so a lot of these kids aren't going to be engineers. But you know what? Those poor kids can become tech majors. What you were talking about, that they start out here. So how many tech people do you have that aren't engineers but need to support the engineers in what they're doing at your company? And then maybe you see an interest in them and they end up going to school at night here at FIT and getting an engineering degree.
And paid by Rockwell, by the way.
Right.
We won't be paid to go to school to learn.
So that's an avenue. It's a way to get there, out of where they are.
Back to your comment, you lean on industry. I can give you a couple contacts. Juliet's the best person for our organization who had to leave. But I can give you her contact information. And that way when you need someone, you can sit in her, she blasts out an email to all my leadership team and says, hey, who can help you with this? We strive to meet them all now, based on projects, based on priorities, based on availability, those things. Usually,
We have not just a STEM, but a STEM.
I'm sorry, I'm gonna have to wrap this up.
I got all night, come on.
No, but I do want to dovetail on the comments.
Can I just close out the presentation? Is that all right? Sorry, I didn't get a chance to finish it. Look, I think we had all the discussions here. The real key point here is that we need people in the community to think not only creatively, but also to think creatively. And that's the key point that I want to make sure you understood. And I want to brag about my daughter here. You know what, it's funny. When I was really young, my parents went out, so we didn't necessarily do the most, we didn't do the best things, let's just say. My wife and I went out to dinner once, and we leave our kids alone. They were old enough, they were okay. She made a makey game on her PC that's all wired with tin foil, where she was stepping on it, and I was like, I don't know where you came from, kid. I was just thinking, these are the things that we do in the community today. So to your point is, well, there's not things that are available in the community. Yes, there are. There are. And it's up to us to build these up so that they're recognized everywhere, right? Not just by, a slide that I throw up here that we all recognize. So just to go around, we support the science fair, we support MPS, Future Problem Solving, we've heard that. First Legally, we've done FIT camps, we do support the academic, social technology, and scientific Olympic. Goes right up the top of that, hard to say. Food Craft Labs is a local place, very small right now, but they are letting the program go to schools locally to do after-school. Stoneman School has it. I know that the Atlantic does. I know there's a couple other schools that are ready to launch, and they're doing it in Orlando as well. So grab them before they get too busy in Orlando. That's a great one for kids to learn how to code at an early age. We have women in aviation where we support girls learning about airplanes and what it's like to be a pilot. And I'm just going to skip this slide just to finish it up. So I want to get back to the end. The conversation that Bill had, we included additional link for other information. I believe this is going to be made available to you. In addition, I tried to capture some stuff for you guys to reference back to later. So some of these things, you may strike a memory and then you go, oh, where did I see that at? Well, hopefully this helps you. These are the different organizations or different things that Rock Collins does in a local area. I tried to put links and descriptions for what they are. So you can see those. There's 2.5 pages, I think, of them. And all these are local events. So look through this. I'll go back. Which one do you want? Which one do you want?
I'll make the slides available online.
Yeah, there you go. Did you get that one? I got one more. You got the last one. Really, one of the things that I'm looking to do is a lot of times companies will invest in the community, but not necessarily in STEAM related or someone says STEAM related.
STEAM.
Prior. I think art is a big piece of what we do. My opinion is anyone that's involved in engineering is really an artist. It's just a different type of artist. You gotta learn to look at that. So interesting going to